Today I'd like to introduce the nomenclature of aromatic compounds. To be able to successfully name aromatic compounds, it will be important to recognize some of the common names that are IUPAC approved. Benzene is the parent compound of the aromatic compounds. Toluene has one methyl group attached to the benzene. Phenol has one OH. Benzaldehyde has an aldehyde attached to the ring. Benzoic acid, a carboxylic acid. And aniline has an NH2 group attached to the ring. The xylenes are dimethylbenzenes, and you'll notice here that a 1,2 substitution pattern is referred to as ortho, so I have ortho or O-xylene. A 1,3 substitution pattern is referred to as meta or M, so this would be metaxylene. And a 1,4 substitution pattern is referred to as para or P-xylene. The polynuclear aromatic hydrocarbons are referred to as PAHs or PNAs. The parent compounds for this class of aromatic compounds are shown here, with naphthalene having 2 aromatic rings attached to each other, anthracene is 3 in a row, and phenanthrene is 3 rings with a slight bend in the molecule. The PAH numbering is shown here, so if I had substituents, I would have to use the numbers that are shown on the rings. You'll notice that the bridgehead carbons, where 2 rings come together, are not numbered. That's because you cannot have a substituent there without destroying the aromaticity of the ring. And if you destroy the aromaticity of the ring, you no longer have a PAH. Many of the aromatic compounds that we see from day to day are heterocyclic. In other words, there is a heteroatom, something other than a carbon, in the ring itself. So all of these shown have either an oxygen or a nitrogen present in the ring. Pyridine is used as a common organic solvent, especially if a mild base is needed, as the lone pair on the pyridine can act as a base. The lone pair of the pyrrole is involved in the aromaticity of the ring, and therefore that nitrogen is much less basic than pyridine. You'll run into pyrrole when you look at the amino acid tryptophan, as the smaller ring in tryptophan is indeed a pyrrole ring. The molecule furan is also aromatic. The name of the carbohydrates in their 5-membered cyclized ring form are the furanoses, and they get their name from this molecule. And you may be familiar with the molecule tetrahydrofuran, or THF, which is a common organic solvent, and in THF the pi bonds are replaced with extra hydrogens, 4 extra hydrogens total. The imidazole ring contains 2 nitrogens in the ring, and it is an aromatic ring using the lone pair that is bonded to the nitrogen containing the hydrogen. The imidazole ring is a portion of the amino acid histidine. Pyrimidines and purines you may see when you're studying DNA and RNA, as those rings are the bases that are present in the nucleosides and nucleotides that make up DNA and RNA. The heterocyclic numbering for the 6 molecules that I've introduced is shown here, and mostly this is just given for your reference if you're asked to look at these compounds in the future. So let's look at how some common organic compounds would be named. In the first example, I have a substituted benzoic acid, so benzoic acid will be a portion of the name. I can either use the ortho-meta-para nomenclature, in which case this would be a para-substituted benzoic acid, or I can use the numbering, which this would be a 4-methyl substituted benzoic acid. So I have 4-methyl benzoic acid. Again, it would be perfectly acceptable to have para-methyl benzoic acid as the name. There is a space between benzoic and acid. The second molecule is often named as a substituted toluene, which means that the methyl group has to be attached to carbon 1. And then if you walk around the ring, you'll see that the nitro groups are attached to carbons 2, 4, and 6. So this is 2,4,6 trinitro-toluene. Trinitro-toluene is often abbreviated as TNT. For the last molecule, I have multiple substituents. I will start the numbering of the ring at the aldehyde carbon because I'm going to name this as a substituted benzaldehyde. I have substituents on carbons 2 and 4, so looking at pieces of the name, I'm going to have a 2-methyl. I'm going to have a 4-ethyl. And I'm going to have a benzaldehyde. We put these in alphabetical order, so the 4-ethyl is going to come first in the name. 4-ethyl 2-methyl-benzaldehyde. For this video, I referenced the Wade Organic Chemistry textbook as well as our McMurray text. And I'd also like to acknowledge the help that was given to me by Professor Gordon Gribble for this presentation.